target? The learning target today is we're going to use angle, angle, side, angle, side, and side, side, side to prove triangles are similar. So, we talked about proportions, we talked about ratios last class, and we talked about if two figures are similar. And we know they're similar if their interior angles are congruent and their sides are proportional, meaning they have the exact same scale factor or ratio. So now we're going to take that and apply it to specific cases with triangles. These order of letters has been something we've seen before. Last chapter we talked about if triangles are congruent, there were 5 postulates. Can someone raise their hand and give me one of our 5 postulates for when triangles are congruent? Maddie was one of them. Side angle side. What's another? No, yeah. What?
That's supposed to be angle.
Angle, just 2. Yep. Side angle side. What's another one? Angle angle side. Somebody new. We have side angle. We have side angle side. We have angle angle side. HL. Side side side. We have one more. We had angle angle side. There's another one that was similar. How do you spell that? Angle, side, angle. So we have 5 postulates for congruency. We only have 3 postulates for similarity, and they are angle, angle, side, 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 and side, angle, side. So the first one, angle, angle. If two angles of one triangle are congruent to 2 angles of another triangle, then those 2 triangles are similar. So if I look at my diagram here, angle K is congruent to angle Y. Angle J is congruent to angle X. Since they have 2 corresponding angles that are congruent, then I know that those 2 triangles are similar. Everybody see how they have the same angle measures, but they're different sizes? That means they're similar. If I'm working with hidden tools, that means there's hidden information that I can pull out of this picture. If I look at triangle SVR and I look at triangle UVT, what type of hidden angles are congruent to each other? Maddie?
Angles SVR and TVU.
TVU. I even like how we use 3 letters there to describe those 2 angles. Those 2 angles are, what's the relationship to each other? They're going to be, angles are going to be congruent because they are, starts with V, vertical angles. Also, if I know that 2 lines are parallel, this line is parallel to this line, then those 2 lines are cut by a transversal, meaning that angle T is going to be congruent to what angle? R. And what would be the reason for those 2 angles to be congruent? Kind of corresponding. Opposite and inside. Alternate interior angles. So, since I know alternate interior and I know vertical, I can use those hidden tools to show that those 2 triangles are similar to each other. My next postulate, side, side, side. If 2 corresponding side lengths of 2 triangles, so AB and RS, AB and RS, AB, RS, they are corresponding side lengths. They match each other in order. If those sides, corresponding side lengths of 2 triangles, are proportional. What does it mean to be proportional? Proportional. Not the same length, but they have the same scale factor. Okay? They have a scale factor. They have a ratio that's equivalent to another ratio. If I look at BC over ST, BC over ST, that ratio of the green lines is going to be the same as the ratio of the blue lines. Also is true for CA and TR. CA and TR have to be proportional to each other, and they all have to have the same scale factor. If that's true, then I know the 2 triangles are similar. So when I look at this picture, how do I know if these 2 triangles, look at the triangles. First one is RQU. RQU, that's this guy. How do I know he's similar to SQT? SQT, that's the big triangle. If they're similar, their sides have to have the same scale factor. So, when I set up my ratios, what are the side lengths of the red triangle? What are the side lengths of the red triangle?
14, 10, and 3.
I like how you went from big to small. So we're going to do that same order. 14 was the largest, then it was 10, and then it was, looks like 9? I think that's a 9. 14, 10, and 9. Okay? What are the corresponding side lengths on the orange triangle? What's the longest one? What's the length of Q to S?
15.
SR is 7, and RQ is 14. So what's the length of SQ?
You have to add them together.
You add them together. Good. So 7 plus 14 is 21. What's the length of ST? 15. But now it's length of TQ.
4.5.
Well, it's TU plus 9. So what's 4.5 plus 9? 13.5. Mr. Ausel, those aren't the same. But what happens if I simplify them?
They would be the same.
What are they all reduced down to? If I reduce 14 over 21, what's a common factor that they both share? I could take out a 7, right? And that gives me 2 over 3. When I take out a 5 here, I'm left with a 2 over 3. And when I put this in my calculator, I get 0.66666, which is 2 over 3. So, all the 3 scale factors have a scale factor of 2 over 3. Since the scale factors are the same, the sides are proportional. Since the sides are proportional, I know that the triangles are similar. Trina? Huh? I added 14 and 7 together to get 21. Oh, sorry, 7. Side angle side. If an angle of one triangle is congruent to the angle of another triangle, meaning that x and m are congruent to each other, and the side lengths that include, what's the word include mean? Included that angle. If 2 side lengths include an angle, the angle is in between the 2 sides. So angle x is between xz and xy, which is also between, angle m is between MP and MN. Since that angle is between those 2 sides, and the sides are what? What do the sides have to be? They have to be proportional. Then I know the triangles are similar. So the angle in between the 2 sides has to be congruent, and the sides have to have the same scale factor, same proportion. When I look at my picture here, which angles are congruent to each other? In my farthest right picture, what 2 angles have to be congruent to each other, and why?
Bless you.
ACB and DCE. Those 2 angles are congruent. What's the reason why, Alec? They're vertical angles. So, since the vertical angles are congruent, and I can compare the 2 sides. Here's triangle ABC, everybody. Which side's shorter, 9 or 18? 9. So 9 over something is equal to 18 is the longer side, right? What's the shorter side on the other triangle? DCE. What's the shorter side? 15. Longer side is 30. Short with short, long with long. So, what's 9 over 15 reduced down to? I divide it by 3. 3 over 5. 18/30. Is it reduced down to 3 over 5? When I divide it by 6, yeah, it does. 3 over 5. So they have the same scale factor, and they have an included angle that's congruent. So, which 2 triangles are similar to each other? Triangle DCE is similar to, and I got to follow the order here really carefully, ACB. I got to make sure I go in the exact same order. Yeah.
For side, is there a symbol for proportional?
Nope.
Like for congruent, it's the line, so.
No sign.
So you
Just say that they have the same scale factor. Kind of show the workboard. Okay?
What you gotta do?
You can set this up, saying that they're all equal to each other. Okay? Alright, so those are our 3 theorems. Okay? And now we have to apply them to specific problems. So let's first look at examples of angle-angle. So we're going to practice using angle-angle postulate, which means we just need to find 2 angles of one triangle that are congruent to 2 angles of another triangle. So when I look at question A, the biggest thing that you're going to have to remember here is I have to identify which triangles I'm looking at. Triangle ABE, that's that guy right there. Triangle ACD is the big triangle. I need to find corresponding angles that are congruent. Which 2 angles are congruent to each other?
52 and 52.
Well, yeah, 52 and 52, right? So that would make B equal to angle C. But Mr. Ausel, you have to be careful about how you name angle B. If I stand at vertex B, I have 3 angles that I can choose from. So I got to pick the specific angle name. Technically, angle ABE is congruent to angle C. So I can say that angle ABE is congruent to angle C. What other 2 angles would be congruent to each other in that picture? Look at the red triangle, look at the blue triangle. What do they have in common? Do they share any letters?
Wait, just
E.
angles? Oh, E.
No. C to D.
E.
What angle, what letter do they share?
A.
A. So since they both lie on A, they both have angle A, they both have an A in them, then most likely they're going to be congruent angles. Angle A is congruent to angle A. Now why can I say that angle A is congruent to angle A? I can say that by the reflexive property.
So now we don't have like a chart, like a.
No, you can always refer back to it if you want, Carlos, as you practice, but remember, on the SOL and Allen test and quizzes, you don't have that chart to look from. So you want to use it lightly. Okay? So those 2 angles are congruent, so that means the 2 triangles are similar. Because if I have 2 angles that are congruent, then I know they have to be similar to each other. So, if triangle ABE is what I'm looking at, what is it going to be similar to? Same order, same order, same order. ACD. It's got to follow that same order. Alright, letter B. DEC and GHK.
Angle D is congruent to
I do know that angle D is congruent to angle G. What do those little boxes mean, Jan? I have a little box there. Letter B, what's that mean? They're both right angles, so if those are both right angles, they have to be congruent to each other. But 26 is going here in angle C. And 64 is over here at angle H, but they're not the same measure. What could I do, or what could I find to determine the other angle measures?
Add 64 plus 90 and then subtract that from 180.
Maddie wants to take 64 plus 90 and subtract that from 180. Or the 2 acute angles in a right triangle always have to add up to 90. So I can take away 64 from 90. And when I do that, what do I end up with?
26?
Yep, 26 degrees. When I take away 26 from 90, I end up with 64 degrees. And all I need to prove is that 2 of the angles are congruent. I need to show that angle C is congruent to angle K, and I can show that angle D is congruent to angle G. Be careful here. Triangle DCE is similar to what triangle? Fill in that blank. DCE is similar to what other triangle? Fill in that blank. Careful with the order. DCE is similar to... Yeah, Erica? G, I agree with that. H, yeah, no.
G-A-H.
G,
GK.
K, H. I have to switch the H and the K because I have to make sure the 26 goes to the 26 and the 64 goes to the 64 in the same order. Okay? Alright, try number C on your own. Try number C on your own here. See if you can find the missing. Always want to identify which triangles they're talking about. CDE is this guy right here. The other triangle is BDA. He's right here. I need two angles that are the same measure on both of the purple and the orange triangle. Can anyone name me two angles that are congruent? Krupa? Angle D and angle D. How do we know that those two angles are the same? By the reflexive property. Very good. Angle D is congruent to angle D by that reflexive property. Since they both share that angle, I know they have to be congruent to each other. I need another one though. Carlos, can you name the two angles that you would think are congruent?
B and C.
Alright, I'm okay with that, but I have to be a little more specific about one of those angles. Specifically C, I have to say what's its name. I need this guy's name right here. Can anyone help me out with that purple angle? What's its name? Yeah, Krupa? DCE. Everybody see that, Carlos? If I'm going from D to C to E, that's representing this angle. So I got to name it with 3 letters. So angle DCE is congruent to angle B because, look at the orange triangle. If he's 33 and he's 62, if I take their sum away from 180, what am I left with? 85 degrees. So 85 equals 85, so they have to be congruent to each other. So finally here, let's fill in the blank. Triangle EDC is similar to what triangle? And I'm on purpose switching up the order of the letters because I want you guys to follow the order of the letters. Because when we look at our chapter 4 test, a lot of us struggle with matching up the order of the corresponding angles. So if I'm going from E to D to C on the purple triangle, that's going to match what letters on the orange triangle? Jan? A, D, B. Good. Yeah?
Can you just do the original order?
Because I'm trying to trick you guys. No, I'm trying to help you practice. I want you to practice that the order of the letters changes. So the other angle would change too.
Like, for the normal problems, can you keep it the original
If they give you this. Okay? Alright, that's angle, but what about side, side, side? The properties for side, side, side have to show me that the sides are all proportional. So they ask here in the directions, determine which triangle is similar to triangle ABC. They give me ABC. They want to say which of these two triangles is similar to this one. Let me let you in on a little hint here. Okay? If I'm trying to show proportionality, I want to create 3 ratios that are equivalent to each other. And if I'm using this triangle ABC, I'm always going to go big to big, medium to medium, small to small. Look at our ABC. Which side is the biggest side? AC, which is what? 16. The next smallest side is?
BC.
Which is 12. And the smallest side is? 8. I want to match those corresponding sides with the same large, medium, small sides on the other triangle. What's the small triangle? What's the large side on the DEF? 12. Then it's going to match up with 9, and the smallest one is 6. I need to simplify these ratios so that they're the same. So using your calculator or in your head, divide by a common factor and see what they all simplify down to. 16 divided by 12, or 12 divided by 9, or 8 divided by 6, all simplify to 4 over 3. Since they have the same scale factor, okay, then I know that this triangle, DEF, it is similar to the other triangle, ABC. But what about the other one? Why doesn't it work? Well, if I go small to small, I get 8 over 8. If I go medium with medium, I get 10 over 12. Is 8 over 8 the same thing as 10 over 12?
Nope.
No, those are not equivalent ratios, which means they are not proportional. So, since these are not proportional, these guys cannot be similar. Okay? They don't have the same ratios, so they cannot be similar figures. Oh yeah. Last one, side angle side. Star. Woo! Determine if these two triangles are similar, side angle side. When I look at the picture here for letter A, I have triangle LNM and JNK. When I look at that blue and purple triangles, which angles are congruent? See if you can write it down on your own. Write it down first. Which two angles are congruent? Which two angles are congruent? K and J is congruent to angle L and M. What's the relationship that those two angles have with each other? Jen? They are vertical angles. So since those angles are vertical, I know they have to be congruent to each other. Now I need to show that the sides are proportional. On the blue triangle, which one's the smallest? On the blue triangle, which one's the smallest? 6. The next biggest is 9. So, which is the smallest side on the purple triangle? 18. Smallest on the other side of the purple triangle? Largest, I mean? 27. So, 6 over 18, 9 over 27. Do they simplify to the same thing? Or do they simplify 2, tricky enough? 1/3. So, since they have the same scale factor, and this proportion is true, and I know I have two congruent angles, then I can use side angle side to show that triangle. Ready, Daniel? Actually, let's go. MLN is similar to what other triangle? LMN. All in the same order. MLN. MLN. Follow your pencil around the blue triangle. MLN. It's going to match with what, Y? KJN. Very good. Cool. Questions? Letter B. Two triangles. Which two? CDB, little guy, and CEA, right there. If we're using side angle side, you need an angle. Which angles are congruent to each other in that picture?
Angle C.
Angle C, right? Is that what you're going to say, Jenna?
Yeah.
What's the reason for that, Jenna?
Because angle C is like it's on both of them.
It's on both of them. Good. So if they're on the same triangle, if I look in the mirror, I see the same thing. What's that called? The reflexive property. So I know by the reflexive property, angle C equals angle C. Also, I need to show proportionality. So I have some sides here. Look on the orange triangle. What's the smallest? Not by much, but which one's smaller? 3.5. Other side is 4. On the, be careful, green triangle. 3.5 is going to match up with, be careful here, I want the length of CE. I want the length of CE.
10.5.
It's actually 10.5. Or sorry, yeah, 10.5. Because 3.5, which is this distance, plus 7 adds up to 10.5. Little plus little equals big. So this is going to be 7. What's 8 plus 4 then on the other side? 12. Are those the same?
Yeah.
What do they reduce to?
1/3.
1/3. So they have a scale factor of 1/3, and they have a included angle that's congruent. So by side angle side, triangle EAC.
It's 10.5 under 3.5.
Thank you.
Did I get it right?
Ooh, look at you. Get that mint. Get that mint, boy. Yeah. All right, 10.5 and 12. EAC is congruent. Is not congruent. Similar to what triangle? EAC, DBC. DBC. Hey guys, just as practice, I want you to try number 1 and 2 below. It's mixed practice, meaning you can use any of the 3 postulates to prove it. So you have to state which postulate you're using and which triangles are similar to each other. To identify that, you just got to look at what they give you. They give me a side, they give me a side, they give me an angle, right? And the angles between the 2 sides. So most likely it's going to be side, angle, side. The only thing I have to check is to see if these sides are proportional to the other 2 sides. So, here, does 24 over 18 come out to be the same thing as 28 over 21? They both end up being 4 over 3. So if the scale factor is the same, they have a right angle that's included, so that makes the 2 triangles similar. By SSS, triangle SRT is similar to triangle PNQ by SAS. So here we've added a step. We've now talked about which 2 sides are proportional. And we've also stated what was the reason for that. Number two. Daniel, look at that. What do you think, man? Those 2 triangles. I have triangle HGJ. Well, no. HGJ and HKF. That's this guy right here. If I have red and orange, green and orange here, what would you pull out of this picture? You could use side, 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 because I gave you all 3 corresponding sides as long as you show that all 3 sides are proportional. Or you could have picked what else? Side, angle, side, because which angles are going to be congruent to each other? The H is shared, right? So here you can pick 2 options. You could use side, angle, side, or side, side, side. Here for side, 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 I need to show that all 3 of these ratios are the same. 3 sides of the green one, 15, 16.5, and 18. Follow that same pattern for the orange. Which one's the smallest? Be careful. What's 15 plus 5? 20. What's 16.5 plus 5.5? 22. And then 18 is going to match with 24. Are all those ratios the same? So, what do those all simplify to? 3 over 4 again. So, either I can show that all 3 of them are the same, or if I just show that this side matches this side, that this side and this side are equal, I can show by SAS or SSS that triangle HGJ is similar to triangle HFK. Alright guys, let's get our drawing on here. Read the word problem. Read the word problem here and draw a picture. Draw a picture. picture here. A flagpole casts a shadow of 50 feet long. At the same time, a woman is standing nearby who is 5'4", and she casts a shadow that's 40 inches long. How tall is the flagpole to the nearest foot? So, first sentence, flagpole shadow of 50 feet. I want to draw that first. So I got a nice base here. Let's draw my flagpole. Mr. also gets into this sometimes, you know.
What kind of flag?
We're going America. America! He's got too much time on his hands, apparently. Not 13 strikes, but, you know, it's pretty close. America. Cast a shadow. So let's put the sun over here somewhere, right? So the shadow's going to be that way.
You have to read this.
No, you can just draw a line if you wanted to. It's fine. But here I have a shadow. That how long is that shadow? 50 feet. That shadow is going to go up to the top of the flag, right? So the shadow casts down from the top of the flag, and it's going to cast a line on the ground. It's 50 feet long. That's the first sentence. The second sentence says that there is a woman who's 5'4", and she casts a shadow that's 40 inches. So here's going to be my lady right here. She's got a little blonde hair, or you want to give her brown hair, black hair?
No hair.
Brunette. Oh, okay.
There you go.
No hair, why not? Very chic. We'll give her like a little, give her a little hair on top there. You know, you never know. All right. Yeah. All right. So there's my lady, which obviously is very large compared to the flagpole, but we're not really drawing the scale here. She casts a shadow. That's how big? 40 inches. Inches. How tall is she? 5'4" So when I look at these two pictures, I have two triangles that, because of angle, are similar to each other. They share a base angle that's congruent, and they both have right angles. Because the sun is so far away, every object from that distance has the relatively same angle of the shadow, as long as they're in the same immediate location on the Earth. Okay, so here I have two triangles. What am I trying to find? How tall is the flagpole? So, how tall is the flagpole? I'm going to put an X in that spot's place because I'm trying to find that value. X marks the spot. So, I need to set up a ratio. X over what?
X over 4.
X over 5'4". However, right now I have different units. I have inches in feet, I have feet. So I need to convert these all to the same unit. But I always want to go down to the smaller unit. So there's 12 inches in every foot. So if she's 5'4", I want to multiply 5 by 12, and that's going to be how many inches? 60, plus another 4 inches, so she's 64 inches tall. Equal to? How tall is how long is the shadow of the flag? 50 feet, which is 600 inches. Good. Just multiplying 50 by 12, that gives me 600. And 40 inches, well, we're going to keep them the same, 40 inches. What we're going to do at this point is cross multiply. So, x times 40, 64 times 600.
40x
Good, 40x.
equals,
Well, whatever 64 times 6
say
is.
12,000. Somewhere around there.
Anybody have a calculator?
12,400.
Need a calculator. 38,400. 38,400 inches. So now I'm going to divide that by 40. And what do I get? 550? 950? Is that right?
I did 64 inches over 40.
x is equal to
In the name.
960 inches. Now, I have to make sure that once I find the value that I was looking for, I have to make sure I plug that back in into the units that they want. In the sentence, how tall is the flagpole? What do they ask for? Nearest foot. So what am I going to take 960 and divide it by? 12 inches, which is going to give me a total height of 960 divided by 12. 80 feet. If you do it, you probably simplified this. You simplified this, and then you did it.
I got it right, but like,
Can't use 5.4 or
you see what I
5.4.
did, Mr. Ausel?
You gotta convert it into inches by making it 64.
Silly dudes.
I got that.
All right. Key concept. Let's skip number 4 here. Let's go to key concept here. Okay? If I have two triangles that are congruent, okay? If I have two triangles that are congruent, let's underneath that space, let's draw two triangles that have the same angle measures and the same side lengths. Let's say I have two triangles here. Let's say this is 5, this is 6, and this is 7. 5, 6, and 7. I'm making up two triangles. They're congruent. They have the same side lengths, and they have the same angle measures inside. So if that's true, if two triangles are congruent, what would their scale factor be? They would have to be the same, but what would it be? It'd be 1 to 1. What's 5 divided by 5? 1. What's 6 divided by 6? And 7 divided by 7? So, since all the side lengths are the same, they all have a scale factor of 1 to 1. So, if two triangles are congruent, they also have proportional sides, and since the sides are all proportional, then those two triangles are similar triangles. So, let me make a statement here. If triangles are congruent, then they are similar. So all congruent triangles are similar triangles, but not all similar triangles are congruent. Only when their ratio is 1 to 1. Okay?
Like, if I simplified it, does that still work if I make the right answer?
Should. Let's jump into some proofs here. Now these go really quick, okay? Because we've already done proofs. It's just now tacking on these new similarity proofs. Whenever you do a formalized proof, what do you always do first?
Given.
The given. So let's go ahead and write down the given information.
You have to say it. 8th graders. 8th graders.
Okay. Now, those two ratios, they say that those two ratios are equivalent to each other. Okay? So if they're equivalent, that means when I look at NO over QO, NO over QO, NO is right here, QO is right there. Those are corresponding sides of the same length. Those are corresponding, not the same length, but they're corresponding sides of a triangle. If I look at PO over MO, those are corresponding sides of different triangles. If I'm using my three postulates, angle, angle, side, side, or side, 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 what other piece of information can I draw as picture to finish one of those three postulates? The vertical angles. Here, if I look at angle, what's the name of that angle right there?
NOM.
NOM. In step 2, angle NOM is going to be congruent to angle.
QOP.
Good, you can follow the same order, right? Go along the red, then the blue. QOP. Those two angles are congruent because they are vertical angles. Yeah. No, see, there's no symbol that we can use. There's no symbol we can use for proportional. But I just want you guys to understand that we're looking at specific lines here, okay? You have to identify which sides we're choosing to be proportional and then use the included angle. Because in congruent we have the tick marks, but here for proportional we don't. No, can't. So, if I'm using those three pieces of information, I can finish with my proving statement in step 3. Triangle MNO is similar to triangle PQO, and what would the reason be? Side angle side. When you're given a proof, what do you always start with? The given. Look at number 2 there. Start with the given. Start with the given. What was given to you to start?
MQ was parallel to Q.
Good. Parallel to OP.
Then they want you to prove M and Q is congruent.
Well, before we use vertical, let's use something else we know about parallel lines. Since these two lines are parallel to each other, and this line, QO, cuts through it, I can use alternate interior angles to prove them congruent to each other. So Q matches with what?
Q matches with O.
O. So I can say in step 2 here that angle Q is congruent to angle O. Couldn't you also say, using the other line, that angle M is congruent to angle P? Sure. Or you can use the vertical piece of information, but either way, you end up with 2 angles that are congruent. So in step 3, let's use angle M as congruent to angle P. And for both cases, for 2 and 3, what's my reason? Alternate interior angle theorem. Alternate interior angle theorem.
What's the difference between alternate interior angles and then the theorem?
Technically it's a theorem because it's saying if lines are parallel, then angles are congruent. If you just say that they're alternate interior angles, it doesn't mean that they have to be congruent to each other. But I'm pretty lenient on that stuff, so if you drop a theorem, I'm not going to freak out. Am I done? No, I got to finish up with what I was trying to prove. My last statement says this triangle is similar to this triangle. So in step 4, MNQ is similar to PON. And what postulate did I use? Angle, angle. Yeah. If you did alternate interior and vertical, it would still work. Yeah. So if you did that, Caitlin, you're fine. We're only going to do 3 or 4. You pick. Which one do you want to do? 4. Stop it! I made my decision. It's going to be 4.
Yay! 4 eyes only.
Oh, look at that. You guys picked the one that has the right stuff filled in, which is easier. Now, let's listen to this real quick, okay? When I'm doing this type of problem where I have to fill in the blanks, I have to really make sure that I'm following what they're asking me to find. So if AE is parallel to BD, where have I seen that? It was given information. So that means I'm going to write given in the space provided here. Actually, guys, 4 is a lot like 3, so if you can do 4, you can kind of do 3. If I'm using corresponding angles only show up when I have lines that are parallel to each other. So which lines are parallel?
BD.
They tell me that BD is parallel to EA. So since those 2 lines are parallel, which 2 angles would be corresponding to each other?
B, D, C,
B, D, C,
and E.
and angle
E.
E. Does anybody find another pair of angles that are corresponding? CBD and A. Mr. Ausel, you saying I could write either of those in there? Yes. Either of those would be correct for corresponding angles. So let's go ahead and say angle CBD is congruent to angle A. Number 3 is wide open. I could use corresponding angles, or, given this picture, what other two angles have to be congruent to each other? C has to be congruent to itself. Because if I look at the two triangles, ACE and BCD, they both share a letter C. So angle C has to be congruent to angle C. And what would my reason be for that?
Reflexive.
Reflexive property.
And the average.
Last thing I need to state is that the two triangles are similar to each other. Your homework is the second page in your practice packet. Make sure, stop packing up, look right here, okay? Make sure that you complete those 2 pages. If you didn't do last night's homework, you got to get that done as well. You doubled up your homework for the weekend, okay? Make sure it gets done. Because guess what, guys? We are almost done with this unit, which means we're going to have a quiz pretty soon. All right?